Okay, so Unit 7 we're starting off with here is going to be about trigonometry mostly. If you've ever looked at a calculator and wondered what the buttons sin, cos, and tan, that's actually sine, cosine, and tangent are, we're going to learn about those in this unit. And it's super fun, and I love it. But it is a little tricky, so make sure you guys are staying on top of all of these videos throughout this unit, because this unit's going to be hard. This is brand new stuff to you. So most of what we're going to be talking about is right triangles. Tri refers to triangles, right? Three-sided shapes. Mostly we're dealing with right triangles. Today we're going to be dealing with a little bit of things that are not right triangles, but all of this unit will be a right triangle. So the Pythagorean Theorem, this is something special and very, very important in a right triangle. We have that a squared plus b squared equals c squared. You may have heard this theorem before on like TV. They use it a lot when people are like trying to sound smart. They're like, oh, a squared plus b squared equals c squared. And they just like say that because it sounds mathy and it sounds smart. What it's referring to, A and B are the legs of the triangle, and C is what we call the hypotenuse. So let's draw a little picture here. This is a right triangle because it has a right angle. And just to recall, how many degrees are in a right angle? 90. So this is a right triangle. It's special. It's like a corner of a room, right? Now, the legs are the two sides that make up the angle. So A and B refer to those sides. We call these the legs. Now, they also are the two smallest sides. Yeah. So you want to write that down to yourself. A and B make up the right angle. They are also the two smallest sides. So C is the biggest side. And if you notice, it does not touch the right angle. So C specifically refers to the side that does not come in contact with the right angle. It has to be this way. We have to plug into this correctly, otherwise we're going to get the wrong answer. So when we're looking at a picture, and you'll see some examples, A and B are always the two that touch the right angle or the smallest sides, and C is going to be our biggest side and the one that does not touch the right angle. Now we also have, we're going to work with here the converse of the Pythagorean theorem. So if you remember, converse means to flip things. So we had in a right triangle, that was first, a squared plus b squared equals c squared. We're going to flip this to say if c squared equals a squared plus b squared, there's a reason we're flipping it there as well. So if this is true, if I plug the numbers in and c squared ends up equaling what's on the right side, then this is guaranteed to be a right triangle. So the Pythagorean theorem only works for right triangles. But what happens when it doesn't work? We can actually figure out something about that triangle. So say instead we plug in our numbers and we get that c squared is less than a squared plus b squared. So whatever's on the left ends up being less than what's on the right. Remember, this is less than, right? Makes a little L. What ends up happening here is this becomes an acute triangle. If you remember, if here's 90, acute is less than 90. That should make sense. That side ends up becoming a little bit less, so that's acute. So if c squared is greater than a squared plus b squared, that's what this says, then, what kind of triangle do you think we have then? This would be obtuse. Remember, if here's a right triangle, but we end up plugging in and finding out that c squared is greater, that's obtuse. So less than acute, greater than obtuse. Now, it's very important you look at it this way, though, because if you switch them, which we'll see in our examples later, it's not going to work out that way. So we're looking at c squared on the left here when we're doing those questions. Now let's start off doing some Pythagorean theorem questions. So what Pythagorean theorem allows us to do is if we know any two sides of a right triangle, we can find the third. So xy is 5 and yz is 12. We want to find xz. We can use Pythagorean theorem to do this because it's a right triangle. Now, what we had to be careful about here is, here's Pythagorean theorem, a squared plus b squared equals c squared. A and b can get switched, but I have to know what c is. So again, C is always the side that does not touch my right angle. So this side right here, is this going to be an A or a B? Those touch the right angle. Or is this going to be C? This is going to be C because it does not touch my right angle. So all I have to do is plug our numbers in then and solve for that missing side. We got 5 squared. Be very careful not to forget the squared. Plus 12 squared. Yes, you could also do 12 squared plus 5 squared. A and B can switch places. C cannot. So we got to be careful with that. Equals C squared. So let's go ahead and simplify this out. 5 squared is 25. 12 squared is 144. Equals C squared. So I believe I know what this is. 25 plus 144. For Pete's sake, I know what it is 169. Now here's where we enter a very common mistake. Have I solved for C yet? No, I have not, because it does not say C equals. It says C squared equals. How do we get rid of a square? We need to take the square root from both sides. You may have forgotten this. It's been a while. The same way that multiplication undoes division and vice versa, a square root undoes a square. So I need to take the square root of 169, and this ends up being 13. There's our answer. So all I gotta do is plug in, be very careful not to forget our squares, and also be very careful not to forget that at the very end we need to take the square root. Okay, try this again. Go ahead and label your picture. What I want you to do is figure out our missing side. Is it going to be an A or a B? It doesn't matter which. Or C. Does it touch the right angle or does it not? Go ahead and try this to label it to start with. Okay, so BC is 7. AC is 25. We're trying to find AB. So does AB touch the right angle? Yes, it does. That means I can choose to call it either A or B. It doesn't matter which. Again, it'll end up working out. I'm going to go ahead and call it A. You would call it B. You're going to get the exact same answer. Because this side touches the right angle, I have to plug it in over here. So I've got A squared plus, here's the other thing I'm going to be careful about. What am I plugging in for B then? What is the other side that touches the right angle? 7. 7 also touches the right angle, so I'm going to plug that in for B. Therefore, 25 is C. So this one's going to be done a little bit differently now. Now we have to get A by itself. We're going to have to move some stuff over. So go ahead. I want you to try this on your own. Simplify it. See if you know how to solve for A. Okay, we got A squared equals, this is 49. 25 squared, I should know. 625. Okay, so once we do that, we need to get the A by itself. So let's subtract the 49 over. So we got A squared equals 625 minus 49. We get 576. Are we done? No, it does not say A equals. It says A squared. In order to undo a square, we need to take the square root. A equals, in our calculators, square root of 576, 24. So, be careful that we understand the difference between these two. Here, I had both sides that touched the right angle, so I plugged in both A and B. Here, we were trying to find one of the sides that touches the right angle, and then we just had to be careful which one is going in for B and which one went in for C. We're going to practice a bit more in class, but that gives us an idea. Try this one entirely on your own, being careful that we are figuring out, am I trying to solve for one of the sides touching the right angle, or am I trying to solve for the side that doesn't? Go ahead and try this one entirely on your own. Okay, JL is 5. LK is 5, and we are trying to find JK. So, notice, does this side touch the right angle? No. Therefore, what letter is it going to be? C. So, we got to plug in. We got 5 squared plus 5 squared. This is my A and my B. Obviously, they're the same, so it does not matter which is which anyways. We've got 25 plus 25 equals C squared. This gives us 50 equals C squared. And then because this is a square, all we got to do is take the square root. Now, depending on what calculator you have, it might give you a radical. It might give you 5 radical 2. In your test, though, it might want it as a decimal, so we'll just kind of be careful. So getting this as a decimal is also 7.07. So either of these answers is correct. I need to take a look at your test and see which way they want you to write it. So this is either radical form or decimal form. Now, this is going to be using the converse here. So when we have a question that says classify the triangle, we're going to be using the converse of the Pythagorean theorem. So remember what this says is we have 3 options. What we are going to do is we're going to plug some numbers in, and we're going to see what ends up happening. If I get equals, less than, or greater than, will tell me my answer. So we have 5, 9, and 10. Now, again, the way we're going to write this, be very careful, guys. When you're doing this specific type question, you want to write it C squared on the left and A squared plus B squared on the right. You need to write it that way when we're doing this specific type of question. So we're going to make a little table here, and we're going to compare what we get on the left side to what we get on the right side. So let's go ahead and try this. Which of these numbers has to be C squared? Because I don't have a triangle drawn, so I don't know which one doesn't touch the right angle. But there was something else we know about C. Which of these numbers has to be C? 10, because it is the biggest side. 5, 9, and 10, C has to be 10. Now again, we're not just looking at C. We're looking at C squared. So on this side, I have 10 squared. Over here, this is my A and my B, or my B and my A. Again, those can switch. That doesn't matter. It just matters what C is. So we have 5, careful, squared, not just 5, plus 9 squared. What we are going to determine is the relationship between the 2 sides of my table. So take a moment and plug in your calculator, get what's on both sides of the table. Okay, so 10 squared is 100. 5 squared is 25. 9 squared is 81. So here's what we have on both sides of our table. 25 plus 81. Okay, so we need to determine the relationship. Because again, if both of my sides are equal, what type of triangle is this? It's a right triangle. And therefore, this cannot be a right triangle, yeah? What we have here is that this side is what in comparison to this side? Less than. C squared is less than what's over here. So, looking back to your notes, if C squared is less than, what type of triangle does it have to be? This is an acute triangle. Again, if C squared is less, think acute, smaller, right? Smaller angle. So this is the way we're going to do all these problems. Set up your table, compare the 2 sides. If what is on the left is less than what's on the right, that's acute. If what's on the left is greater than, that's obtuse. If they're equal, it's right. Let's try it again. Okay, so we're going to get our setup here. We're comparing C squared and A squared plus B squared. So looking at these 3 numbers, be very careful. Which number is going to be C? 29, the biggest number is always going to be C. And then we have our A and our B. Notice that I'm choosing 21 to be A and 20 to be B. It doesn't matter. I can flip-flop it. But we have to remember to square them regardless. Do not forget that. Okay, take a moment, your calculator, go ahead and get these. So 29 squared is 841. 21 squared is 441. And 20 squared is 400. And let's go ahead and get this one more step. We've got 841 over here. That only took us one step. And hey, if we add these together, this is also 841. So is c squared equal to, less than, or greater than what's over here? Equal to. These are equal. So what type of triangle does this have to be? A right triangle. This is Pythagorean theorem, and it only works for right triangles. Trying the last one. So this one's a little bit tricky. We're still going to do c squared, a squared plus b squared. But I need to figure out my biggest side, right? We've got 7, 10, and 4 radical 5. In order to plug in for c squared, I need to know what the biggest side is. And I actually don't know what 4 radical 5 really is. So what we need to do is plug that into a calculator and get it as a decimal and figure out if it's going to be bigger than 10. Because it is possible, actually, that it could be bigger than 10. And then that would need to be c. So take a moment, plug 4 radical 5 into a calculator, and see what you get. Okay, 4 radical 5 as a decimal is 8.9, roughly. So I have 7, 10, and 8.9. Which one is going to be c? 10. So now we can know for certain that 10 is the biggest side. So go ahead and try from here. You can go ahead and plug in 8.9 instead of 4 radical 5. You can do that. Actually, I lied. Plug in 4 radical 5. You need to do 4 radical 5 squared. Go ahead and write it out, and I'm going to help you out. Okay, so we've got 10 squared. So we have 7 squared is my A. Plus, what you need to do here is put this in parentheses and go 4 radical 5, close parentheses, squared. This is where I recommend you guys really need to use Desmos if you don't have a nice calculator. Guys, doing radicals on your phone is not the business. It doesn't work nicely. So do not do radicals on your phone. Open up Desmos real quick, parentheses around the whole thing, and then square it. So take a moment and use the Desmos calculator if you need to, or if you have a nice calculator, you can type it in like that. Go ahead and simplify this out. Okay, we've got 100 on this side. We got 49 plus, I'm going to type in parentheses, 4 radical 5, close parentheses. Oops. Close parentheses, squared. I get 80. So there's a reason why you want to use this exact number, because if I used 8.9 and squared it, I'd get very close, but not close enough. Yeah, we want it to be exact. So we have 100 on this side, and we have 49 plus 80. We got 129. So what do we think? Is c squared equal to, less than, or greater than the 129? It's less than again. So this is, once again, what type of triangle? This is acute. Once more, if these were switched, if it was 129 on the left side and 100 on the right, this would then be obtuse because c squared would be greater. So again, guys, with your homework, we're going to practice in class a couple times before you try the assignment. Be very careful. Don't get lazy and just use your phone because you don't want to pull up Desmos. You will probably get the wrong answer if we're not careful. Yeah. We're going to practice a bit more in class before you guys try your assignment. Hopefully it's making